we will be drunk and all of the thumbs went up in the air. Singing in the wind, listen to the thunder rolling over and over. We down, we're getting on fire, we're raising up higher. The bottle is up, we're over the.
Okay, thank you very much. Welcome to another section of chemistry. We have some question here we need to treat. Okay, now again we have the question that goes thus: an isotope has an atomic number of 15 and a mass number of 31. How many protons does it contain? An isotope, that means an atom. Atomic number, mass number. Don't forget, this is atomic mass or mass number. This is atomic number. So I told you that this atomic number Z is equal to number of protons is equal to number of electrons. They are equal. So if the atomic number is 15, it means proton number is also what? 15. That is the answer. But if it is number of neutron is A minus Z, meaning mass number minus 15. That would be 16. Take note of that. Okay? So the answer is still 15. That is the number of protons. The number if they ask how many electron, the electron is also 15. If they ask you the electronic configuration, EC, how the electron are distributed, the first shell will carry 2 electrons. The next shell will carry 8 electrons. 2 plus 8, 10 out of 15. The third shell will carry 5 electrons. So that is it. So the electronic configuration is 2, 8, what? 5. Okay? Take note of that. The first shell always carry 2. The second one can carry 8 or less than 8, depending on the number that is here. The same thing, the third shell cannot carry more than 8 for the first 20 elements. So it can carry 8 or less, depending on the situation. Next question now. Which of the following is not an alkali? Sodium hydroxide, calcium hydroxide, magnesium hydroxide, and ammonia. NH3 is ammonia. Take note. Now, alkali means base. You know, we have acid and base. This one is base. It's also called base. Okay? Now you recognize base. You see this hydroxyl ion, OH attached. Any compound that you see this hydroxyl ion is a base. You can see it here, you can see it here, you can see it here. It's not here, so this one is what they are referring to. But mind you, this ammonia, if you mix it up with water or you moisturize it also behaves like a base sometimes. But when it is dry, it behaves like a gas, ammonia gas. So ammonia gas is NH what? NH3. So that is the answer. That one is not an alkali. Okay? Okay, we still come across question later. Now, look at this. Hardness of water. We are going to spend some time on this also. Hardness of water is mainly due to the presence of. Now, we have 2 types of water. Water can be hard, we call it hard water, and it can be soft. Now, this hard water are gotten from where we have calcium carbonate, where the rock is contain this substance, calcium carbonate or magnesium carbonate. Now, what actually causes hard water to be hard, is that it contains calcium and magnesium ion, calcium 2 plus and magnesium 2 plus. These 2 ions make water to be hard. Now, when water is hard, if you use just water to wash clothes using soap, it will waste your soap because there will be formation of what we call scum. This scum will not allow the water to foam or to lather. And if your soap did not lather, you will not enjoy washing your cloth. That is the disadvantage. And so because of that, any water that is hard, if you are using it to wash clothes, it will waste your soap. It will waste. Take note of that. It will waste your soap. Now that is the advantage. So when you have hard water, it is advisable you use detergent, Omo, Viva, all those detergents, anything detergent. Use detergent because detergent overcome the formation of scum. It will neutralize it. Do you understand? And so you get a lather or a foamy water and you'll be able to enjoy it. So that is one of the advantage of using detergent in hard water. Now, hard water has advantages. The advantage is that it contains this calcium and magnesium. You remember that calcium is good for bone and teeth development, your teeth and your bone. Children are encouraged to take supplements that contain calcium. Okay? It strengthens your bone. So, even though the fact that something is bad in a particular aspect does not mean that it will not be useful in another aspect. Everybody has his own positive and negative side. That is why you must not criticize or judge somebody on the surface. Okay? So it means that salt water, then again, this hard water, because they contain these minerals, ions, they have taste. Is that clear? It has taste. So those are the advantages. So don't forget, hard water wastes soap, but you can overcome that by using detergent. Do you understand? So water is hard when it cannot form foam or lather due to this formation of what is called scum. Scum formation can be neutralized when you use detergent. Okay, now still on water. Water treatment. How do you purify water? You take it through so many processes like filtration, sedimentation. Before sedimentation, you have coagulation, and so on and so forth. But I'm interested in some aspect of water. Now, there are some, in the process of treating water, there are some chemicals that are added. Let's look at the chemical. Number one is carbon. Why do you add carbon in the process called carbonization? Water is carbonized to remove taste and odor. If you harvest water freshly, it will be tasty, it will how it smell, so you carbonize it. Chlorine. Why do you add chlorine in the process called chlorination? To kill germs. Fluorine. Why do you remember that fluorine is part of the composition of toothpaste that we use to brush our teeth? Why is fluorine in toothpaste? Why is it also used in the treatment of water? To prevent tooth decay. Then in the process called fluorination, iodine. Okay, in the process called iodination, to prevent goiter formation. Goiter. In a Yoruba land, we call it belubelu. You see, there's a particular gold that normally gets protruded in people's neck. Okay, you remember that we have what's called iodinated salt. Iodinated salt is also an attempt to prevent goiter formation. Take note of that. So then we have potash alum. Potash alum is used to settle down particles inside water, to bring them together, to form a solid so that they'll be able to settle down and you'll be able to filter up or decant the water. So potash alum brings together invisible small particles inside water in the process called coagulation or flocculation. Take note of that. So this is very important for you to note. Well, 30 minutes. Let me.
30 minutes.
In the process called flocculation. Take note of that. Now let's move on with our. Now look at this question they ask you here. They're asking us that which of the following pollutant is associated with brain damage? Is it sulfur oxide? Is it carbon dioxide? Is it biodegradable waste? Is it radioactive fallout? I think it's sulfur oxide, SO2. Sulfur oxide, SO2. Okay. Now chlorination. Hey, look at this. I've just treated this. Chlorination. That means adding chlorine. Chlorination of water for town supply is carried out to A, remove odor odor from the water. No, that is carbonization. That is carbon. Remove germs from the water. Yeah, that is the answer. Make the water tasteful. No. Then make the water colorless. No. The answer is to remove germs from the water. I've just treated that. I didn't know that they are going to ask a question related to that. Now look at this. The number of hydrozonium ions produced by one molecule of an acid in aqueous solution is its concentration. Okay? Not pH, not acidity, not basicity. Basicity, I've treated that one in the previous video. So don't let me go into that, but we don't have time. Now, look at this. Listen to this. A solution whose pH cannot be easily altered due to accidental addition of acid or base is called buffer solution. A buffer solution, you cannot alter the pH value by adding acid or base. Is that clear? We call it buffer solution. Take note of that. Now look at this. Detergents are more advantageous than soap in hard water. This is true because on treatment with hard water, they form more lather than soap. Form soluble sodium salt are converted into liquid soap. Form soluble calcium salt. No, they form more what? Lather. I've said that today. Okay, detergent has more advantage. If you use soap, it will form scum. Scum will not make your water to lather or to foam. But if you use detergent, that is the advantage. It will foam and you'll be able to enjoy the washing of your clothes. The next question, please. A major effect of oil pollution in coastal water is the destruction of marine life, desalination of the water, increase in the acidity of the water, the detoxification of the water. No, oil pollution affects coastal water by destroying the marine life. All the animals, everything, plants inside the marine environment will be destroyed. So that is the answer. Now, the next question. The depletion of ozone layer. This is climate change. Please, I will advise you to go and Google climate change and read as many things you can get about climate change. Everywhere now is about climate change. So these are likely to be a global question. You know, Olympiad is global. Go to Google and get as many information as possible. I have a write-up on climate change, but time is not our side. You just have to move on. So there are some things I will need to tell you to go and Google. There are some information you can Google because it's a global thing. And at your level, they can ask you anything on climate change. Now, the depletion of ozone layer is caused by the release of dash in the atmosphere. Is it chlorofluorocarbon? Is it oxide of sulfur? Is it oxide of carbon? Is it oxide of nitrogen? Okay? The depletion of ozone layer is caused by the release of oxide of carbon. Oxide of carbon. To be precise, carbon 4 oxide, which you can also call carbon dioxide. The next question. Which of the following is not an example of chemical change? Now, we have chemical change. I'm going to address this as a topic before next week. Then we have physical change. Chemical change is a change that takes place in a reaction that is not reversible. It is not reversible. Physical change is reversible. For example, if you put a cup of water in a freezer, it will turn to block, ice block. Now, if you remove the ice block from the freezer, it will turn back to what? Water. That's physical change. Okay? But chemical change, once it happens, it happens. If you use your salt and your maggi and your pepper and oil to cook, and you now have soup, you can't get all this thing back again because a chemical change has been taking place. Now, so we'll talk more about that, but let's see the question here so that I round up this particular segment. Now, look at this. They said, where is the question? Where is the question? Which of these is not an example of chemical change? Fermentation of starch. One starch ferment, you can't get it back. Rusting of iron. One iron rust, you can't get it back. Sublimation of solid. Yes, that is the answer. Sublimation means a substance passing from solid state without passing through the liquid what? State. It will just go to what? Vapor or gaseous state. Another name for gaseous, vapor is gaseous. Normally, when substance transform, they transform from solid to liquid to vapor, and from vapor to liquid back to what? The substance that sublime moves straight from solid to what? Vapor. They bypass liquid state. Do you understand? So that means if a substance move from solid to what? Vapor. If you remove the temperature, it come back to solid again. Is that clear? So this is physical change. It can go this way, it can come back. Do you understand? Okay. When it can solidify and become solid again. So they said dissolution of metal and limestone in acid. If you dissolve metal or limestone is what is used to produce cement, calcium carbonate. Limestone is also the same thing as chalk, limestone are used to produce cement. The chemical name is calcium carbonate. If you dissolve this in any acid, maybe HCl, it will give you calcium chloride. Carbon dioxide will remove. Because there is hydrogen and oxygen, water will be produced. Take note of that. So you can, once this form a new compound, you can't get it back. You can't get back that calcium carbonate. So those ones are chemical change. They are irreversible. So the answer there is only sublimation. And what are the substances that sublime? Iodine, sulfur, spirit, all those substances sublime. They turn from solid state to gaseous state. I'm going to just give me like 3 more minutes, okay?
Yeah.
The camera person, our cameraman. Which of these gases is used in production of fire extinguisher? That is carbon dioxide. Don't let us waste time. Carbon dioxide, or another name for carbon dioxide is you say carbon 4 oxide. Carbon 4 oxide is called carbon dioxide because there are 2 oxygen. It's used in the production of fire extinguisher. Now, I have 3 more questions here for this round, for me to round up this particular. Take note, a lot of things, a lot of information are provided. So please, just settle down, revise, go over them, the video, up and down, and then you'll be able to have enough information. The solution of pH 7.9. Now, pH value is from 0 to 14. pH value, pH meter. At the center, we have 7. That is water, H2O. Pure water is neutral. Neutrality is 7. Now, we have 1, 2, 3, 4, 5, 6. Then here we have 8, 9, 10, 11, 12, and what? 13. As you go this way, the acidity increases. As you go this way, the alkalinity increases. Then water is neutral, 7. Any compound that reads pH of 7, it means it is what? Neutral. It is neutral like water. But all this one, so it means that a solution with a pH of 1 is more acidic than the one with 6.5. Do you understand that? It's more of an acid than the one with 6.5. It's more of an acid with more of 4 or 5 or 3. Is that clear? Now, but for a base or alkalinity, a pH with 14 is more alkaline than the one with what? 8. Is that clear? So it means that acidity increase this way. Alkalinity increase this way. Take note of this question. Okay? Now in this question they say the solution, so they gave you a solution that is having a pH of 7.9. 7.9, is it before 7 or after 7? 7.9, that's after what? So that means it has fallen into what? Alkaline. It's fall, yeah, because this is 7.128 this way. Anything after 7 is alkaline. Everything before 7 is acid. Okay? So they said amphoteric, B acidic, C neutral, D basic. Another word for alkalinity is what? Basic. So this is basic. Okay? Neutral. Neutral is when a pH is what? 7.0 or 7. Now take note that pH plus pOH give us 4 must equals to 14. Is that clear? Do you understand? pH plus pOH equals to what? 14. Now, let's look at the last two. Please come closer here. When heat is absorbed during a chemical reaction, the reaction is said to be, now, when two substances react, A plus what? B. This is reactant. What do I call it? It gives you product, C plus what? D. This is product. Is that clear? Now, for reaction to take place, there must be heat change. Delta H, there must be heat change, enthalpy change. Now, if the heat change is positive, it means it is called endothermic. And what? It means that for this reaction to take place, heat is absorbed. Heat absorbed. Absorbed. So if you see an equation and they write maybe plus 780 kilojoule per mole, know that it is what? Endothermic. Endo means inside, in, it is absorbed. But if what you see is maybe negative, then it is exothermic. Exo what? It means it is released to the atmosphere. It is released. Or it is given off. So take note of that. So look at this question. They said when it is absorbed during a chemical reaction, the reaction is said to be A endothermic, B exothermic, C thermodynamic, D isothermal. What is the answer? Endothermic. It is being absorbed is endothermic. It is being given up or is being released is what? Exothermic. And if they give you, they can come this way, they can write an equation. In front of that equation, they give you the energy change. If it is plus, it's endo. If it is negative, it is what? Exo. Okay? Negative is always conspicuous. Positive is always ed. It's there, but you will not see it. Endo. In. Finally, the last question for today. When large hydrocarbon, you know I told you about hydrocarbon, substance with carbon and hydrogen only. Now, when large hydrocarbon, an hydrocarbon is large if the carbon content is very high. Let's say like C20, 20 times 2, 40 plus 2, 42. This is very large. It has a very large carbon content. Okay, now, when large hydrocarbon molecules are heated, when you heat it, apply heat. Okay, in the presence of the catalyst, to give smaller molecule, the process is known as, is it disintegration? No, we have that one in radioactive substance. Is it degradation? No. Is it distillation? No. Is it cracking? Yes. We call it thermal cracking. It will break it up into two substances of lesser carbon content. We call the process thermal what? Thermal cracking. Now, disintegration, that one is under radioactivity. Radioactivity. Okay? The nuclei of a radioactive element disintegrate to produce alpha, beta, and gamma party and also release energy. We are going to treat that. So, but in this case now, when you apply heat, high temperature to a case or to certain hydrocarbons to produce smaller one, the process is called thermal what? Cracking. So much information again I've been able to provide. One question we lead us to about 5 other questions. 2 questions leading us to about 7 other questions. And so we have a lot of information that can really help you in imagine the best in FCT or in Nigeria. So all you need to do is to keep on reading, keep on revising. The first round of this examination come up 21st of Saturday. All I can just do is to wish you the best. We still have more production. I'm still coming back to mathematics. It's been very hectic for me this day, but mathematics is still coming up. And then there's some topics I want to address. This will continue till next week, Wednesday. Expect more videos on this. Just keep on reading. I want to see you emerge as the champion in FCT under the Junior Science Olympiad, including that of the mathematics. See you. Thank you.
Down the river we drunk and